All right, in my final video on graphing reciprocal trig functions, I want to look at cosecant and secant. We've already talked about tangent and its reciprocal cotangent. So in looking at cosecant and secant, they really are a lot easier than you might think. And the big thing for graphing something like cosecant, which we can start off with, is understanding what its reciprocal function sine actually looks like. So I'm going to go ahead and I'm going to graph my sine function as a guide. That's why I have it written here. So what do we know about sine? We know that the sine function has an amplitude of 1. And actually, let me actually do this in a different color. We know it has an amplitude of 1 and its period is 2 pi. So using that information, I'm going to go ahead and label my axes. I'm going to go ahead and write this as 1 here, -1. Might as well go up to 2 since just want to make sure we're being complete here. And I want to graph 2 full periods. Let's start at 0. And then if I want to graph 2 full periods, since I know 1 period of sine is 2 pi, let's go all the way up to 4 pi. So if I make this 4 pi, then that means this would be, I think this is right. 2 pi, yeah, here we go. So 5 pi over 2, 3 pi, this would be 7 pi over 2. Okay, so I've got my x-axis labeled. And what I'm going to just do now is I'm graphing sine right now. That's the key thing to remember. Right now, I'm just going to graph sine. And I'm going to do it in like a dotted line just so that you can see kind of generally what the shape is. Because I'm using this as a guide in order for me to graph cosecant. So for sine, I should remember that it goes mid, high, mid, low, mid, or intercept, maximum, intercept, minimum, intercept. And I'm just going to keep it going here. So what I'm going to do now is I'm just going to graph in a kind of a dotted line here. I'm just graphing sine as a guide. So everyone should be able to do this at this point, just graphing sine. Okay, so there's my sine graph. And here's what I just need to remember about cosecant. And just for that cosecant, let me just switch gears. Cosecant is the reciprocal of sine. It's the reciprocal of the outputs of sine. So you could literally just go through these points here and find the reciprocal and graph it. So starting with 0, 0, that point, what is the reciprocal of 0? Well, the reciprocal of 0 is just 1 over 0. So that would actually give me a vertical asymptote. So wherever there is a, let me just make this a little bit larger. So wherever there was a 0, you can actually just draw a vertical asymptote there. And that one is crazy. I don't know what's going on there. All right. I'm just going to do this because I think it actually might be faster than switching back and forth. So wherever there was a 0, we can draw a vertical asymptote there. Whenever sine gives you an output of 0, cosecant, its reciprocal, would give us undefined. Now, let's think about all the other places. What is the reciprocal of 1? Well, the reciprocal of 1 is still 1. Ooh, I should probably change that size. The reciprocal of 1 is still 1, right? And to get a really better sense of what's going on here, let's just kind of arbitrarily choose a point like, let's say like 1/2 here. And ask yourself, what is the reciprocal of 1/2? Well, the reciprocal of 1/2 is 2. So where the graph would actually give us an output of 1/2 for sine, it would give us an output of 2 for its reciprocal. And just think about these values that like really close here, that are really close to 0. What's 1 over the reciprocal of something that's very close to 0? It would be something that's really, really large. So we see actually these values are actually going to look something like this. Because as the sine values get very small, their reciprocals are going to get very large. So the result is a graph that looks like this. So for these branches, you honestly, I'm not really particular about you plugging any points, about making them super accurate. You can just graph that value here and draw values that are decreasing and approaching the vertical asymptote. So this sine graph is going to look just something like this. So the easiest thing, or the easiest way of graphing the cosecant graph that I can kind of advise students on is just think about what the graph of sine looks like and find the reciprocals. It's that easy, okay? And on that note, let's go ahead and do cosine and its reciprocal secant. So for cosine, and I'll do this in blue as well, we know its amplitude is 1, its period is 2 pi. So I'm going to use that to label my x-axis just like we did before, and I'm just going to kind of just actually copy and paste this. I know that's kind of cheating, but we'll see. Hopefully this works. There that is. All right, and 1, 2, -1, -2, and I'm going to graph cosine in blue. So cosine starts off at its maximum, mid, low, mid, max. I'll just continue this on. So we're going to get something that looks like this. Oh, you know what? I want this to be dotted, and this probably is a good lesson. We want this to be dotted because if you draw it as a solid line, then what you're saying is that's where the function is defined, which is not the case. Again, we're just doing this so that we have a guide as to what secant actually looks like. And students also ask me, do I have to draw the guide? And the answer is no. I'm doing this early on because it's our first time seeing this, but if you moving forward, if you want to just go ahead and just start graphing the reciprocal, you're welcome to do so. So again, wherever there was a 0, I'm going to graph its reciprocal, which is just means it's undefined there. And everywhere else, we're going to do the same exact thing. We're just going to find the reciprocal of 1, which is 1. Reciprocal of a fractional value less than 1, which means it's going to start shooting out towards infinity. And that's all there is to it. So you might be asking yourself, what is one full cycle of secant look like? Well, we know that one full period is from 0 to 2 pi, so it would really just be everything from here to here. That's actually one full period of secant. Okay? All right. Now let's do, for the final one, let's do a cosecant graph with a transformation. So we're looking at y equals 2 cosecant of 2x. So there's some transformations going on here. And again, I would recommend just looking at the graph of y equals 2 sine 2x as its guide. So let's look at what we know from here. I'm going to change my color again. So we know that the amplitude is going to be 2. We know that its frequency here from this is going to be 2, which means the period is 2 pi divided by 2, which is pi. And the period divided by 4 is pi over 4. So using this information, let's graph what we know. I want to make sure that my y-axis has enough space to graph up to 2. So I'll go 1, 2 here, -1, -2. On my x-axis, I don't have any horizontal shifts I have to worry about. So let's just graph enough to make sure that we have a period of pi. So let's go from 0, make this pi, which means this is pi over 2, pi over 4, 3 pi over 4. Okay, so we got our axis labeled. So in blue, I'm going to go ahead and I'm going to graph 2 sine 2x. So I'm graphing 2 sine 2x first as a guide. So mid, high, mid, low, mid. So we're going to get something that looks like this. Dotted line to indicate that this is not my actual function. This is not where it's defined. It's just something that I'm using as a guide. Again, I want to graph asymptotes wherever there was a 0, because the reciprocal of 0 is undefined. And then from there, I'm just going to graph. Oops. Let's chill out on that a little bit. All right. Just going to graph these. Okay. So there's my graph. But before I end the video, I do want to highlight something. Some of you might be looking at this and there might be a small part of your soul that's a little confused or something's eating at you. And the question is this, wait a minute, what isn't the reciprocal of 2 equal to 1/2? So then why is my value still here at 2? Pause and think about what I'm asking. We know the reciprocal of 2 is 1/2, so why is my graph still starting out at 2? Well, if you've thought about it, the answer to that question really lies in the fact of the following. What are we actually saying here? We're saying that y is equal to 2 cosecant of 2x. 2, this is the same thing as writing times 1 over the sine of 2x. So let's choose a place where we're having a maximum. So something like, let's say, for example, pi over 4. 2 times 1 over sine of 2 times pi over 4. A lot of parentheses going on there. What are we actually saying here? This is the same thing as 2 times 1 over the sine of pi over 2, which is 1. So that's 2 times 1 over, excuse me, 1 over 1. That was actually right. And that's equal to 2. So the reason why I'm going over this is because, yes, the danger might be to think, oh, I'm just going to take all the y values there and find the reciprocal. That is technically what we are doing. But remember, this is always in the context of what's happening to the function. And the function said it's 2 times the cosecant of 2x. And for that reason, it's the reciprocal of the sine of 2 times whatever that input is. And so you're going 2 times the reciprocal of actually 1 over 2 times the reciprocal of 1 there, which is what results in 2. And so that's why we're okay with just writing that value there. Hope that helped. Again, more practice problems, the better you're going to be at all this. But hopefully this gives you a good sense on how to graph all the reciprocal trig functions.